Good morning, students. So, till date we came to know about Coulomb's inverse square law and limitations of Coulomb's inverse square law and charge densities. Now, in today's class, we are going to get idea about electric field lines. Electric field lines. So, how they are imaginary lines? You may not able to see with the naked eye. So, how they are spread over the surface means for a positive charge, always electric field is directed away means this is a positive charge and here is the field line which is moving away. Similarly, all the field lines which are acting on the surface of positive charge are moving away from the positive charge. So you can say this is at a high potential. So similarly, if you draw these electric field lines from the negative charge, they are also imaginary field lines. If you are drawing these lines, how to draw means you will get this structure for a spherical charge. They are moving towards the charge. Observe the arrow mark. All the electric field lines are moving towards the charge. And one more thing. In which direction the field is? I told here, since it is a positive charge, its direction is moving away from it. And since it is a negative charge, its direction of the field is towards negative charge. But why? So we have a test for this. Consider a positive test charge, Q naught. Consider a positive test charge. Every time we will consider a test charge, positive test charge only. If you consider this one and you are trying to place anywhere in the region of this positive charge, I mean here if you are placing means, it will experience a force which is acting away from the positive charge. This will experience a force. Q naught will experience a force. So remember this. This is placed in the field of this one. So this field belongs to this charge, not this one. This charge. That is why this Q naught is repelled by this positive charge along the direction. This one. This is the direction. Along which you can decide. Along which the force is acting, that direction is said to be direction of field. Since the repulsive force is acting between this positive charge and test charge in this direction, so in this direction only, moving away from this. My hand is moving away from the charge in this direction. So this is the direction of field. Similarly, if you place a Q naught anywhere here, these are the direction of the repulsive forces due to placing of this Q naught, due to this one. Okay. Come on to the same positive test charge, you are placing here now. Since they are opposite charges, there is the attractive force between this negative charge and a positive test charge. And thus force is towards negative charge. Towards negative charge. and this whole field is belongs to this negative charge only. Even you are placing this q naught here somewhere else in the field, that will definitely attracted by the negative. That is why the direction of this field is decided towards negative charge, the given charge. So here you came to know how the positive charge is moving away from this positive charge, and how the force is acting here, and how the field is directed towards this negative charge. Why it is? Why it is? You came to know with a practical example. Now, come on to the this one. Suppose if I place one positive charge, one negative charge, one positive charge, one negative charge in air medium, in air medium. Why I am saying air medium means, if I took another medium, if I took another medium of permittivity epsilon, that will definitely vary, that the force the vary with the force which is in which you are placing this one in a different medium. Suppose you are placing in a air medium these two charges, the permittivity of air or free space will be epsilon naught. If you are choosing other than the air medium, then you will get another permeability, that is E. And what is the relation between these two? This is equal to a relative permeability. So permeability of free space will never change, but permeability of medium will change. So while doing problems, we need to know that how it will vary with respect to permeability of free space, that how many times it is going to be increased or how many times it is going to be decrease. You need to get idea. So we will discuss it later once again. When I place these two charges, positive and negative, you all know that since it is a positive charge, the field is directed away from the positive charge. Very easy. Away from the positive charge. Observe this all directions. And since it is a negative charge, this field is directed towards the negative charge. So this is how electric field lines are acting between two charges which is an attracting condition. I mean two opposite charges. Suppose if I am taking two similar charges, either positive charge or negative charge. I will draw here, check it once. This is a positive charge and here it is another positive charge. How the field lines? Look, since it is a positive charge, the field is directed away from the charges, right? And here, this field line will bend like this. It is a bend. They never interact each other. It is bent. When you are pushing and pushing, they will try to move away from each other. So field lines which never get interact like this, they will get repelled due to a repulsive force between the two charges. These field lines are arranged like this. Okay, these field lines are arranged like this. Please draw. Pause the video and draw it once. And those lines were drawn. So come on, let's check this one. Observe this one. This is a positively charged body. Inside the positive charge is present. Long charged body. It is not point sized like this. Long charged body. When you are having long charged body, these electric field lines are moving away from this charged body. Okay. Here, these electric field lines also called electric lines of forces. Lines of forces. That means force, direction of force acting on a positive test charge when it is placed here. Since the force is acting away from this one, Q naught, like this, and away from this positive, like this, sorry, away from positive rod, like this, and this line is also decided as direction of force, this direction of force is directly proportional to electric field strength or electric field intensity. This force is always directly proportional to, F is always directly proportional to electric field strength or intensity of electric field. And how this forces get calculated? Once you want to calculate the force between these two, or from here to this, if it is a negatively charged body, or here it is a positively charged body, how to calculate? Or between 2 point charges Q1 and Q0, how? Since it is placed in the field of this one, we need to consider force experienced by Q0 due to Q. You can't say force experienced by Q due to Q0. Why? Because Q0 is placed in the field of Q. So this is your headmaster, this is your master, and this is your test charge. So while saying or while constructing your statement itself, you need to be right like this. This Q0 will experience a force, and if Q0 size is increased, I mean here one electron is present, it will experience a force. One proton is present, it will experience a force. If two protons are present, it will experience more force. If 10 number of protons are present, it will experience more force. So this is how, if Q0 is get increased, the force experienced by this Q0 is also increased. Okay. So, sorry, this I will change now. F is directly proportional to Q. F is directly proportional to Q. So, previous our statement is very sorry. This Q0 will experience more force due to Q, and the size or magnitude of Q0 get increasing further. Then the force experienced by this one is increases. That's what I written here. Force directly proportional to Q. To remove this proportionality symbol, we need to observe once again this one. This field, we need to observe. What type of observation? Which is constant here? These two are playing game. That means this positive charged body, this Q0 and this force, all are playing game, and one is the constant. What is that? Electric field. Electric field intensity or electric field strength is constant. That constant leads main role. What is that constant? Electric field intensity. And what you are observing? Force experienced by Q0. Where? There or here? Force experienced by Q0. And force, this one. This is the force experienced by Q0. This will increase when its size increases. This will decrease when its size is decreasing. But in the presence of a constant electric field, it will happen. So when you are removing this proportionality symbol, you need to take a constant and is equals to F is equals to EQ. You got a formula. Please repeat this video or pause this video and listen these statements. One thing, students, you are learners. You are not a professor or well experienced teacher to understand this concept at a time. That is why I am asking you to repeatedly listen the lesson. Try to download this one and repeatedly listen this same concept. Then you may get idea and you will get you will become very professional in this context, in this concept. I told you to this one once again. You are learners అంటే నేర్చుకునేవాళ్ళు. మీకు ఒకేసారి ఇంత కాన్సెప్ట్ అర్థము కాకపోవచ్చు, తప్పు లేదు. అర్థము కాకపోవడం అనేది జరిగినప్పుడు మీరు మళ్ళీ వినండి. సేమ్ చాప్టర్ సేమ్ వీడియో మళ్ళీ వినండి. ఎక్కడ అర్థం కాలేదో దాన్ని తెలుసుకోండి. డౌట్ ఉంటే మెసేజ్ పెట్టండి. ఓకే, యు ఆర్ జస్ట్ లెర్నర్స్. ఓకే, లెర్నర్స్. మేము నేర్చుకుంటున్నాము అని మనసులో పెట్టుకొని వింటే అర్థమవుతుంది. ఒకేసారి వినంగానే వచ్చేయాలి అంటే ఎలా వస్తుంది సార్? రాదు. ఇట్ విల్ టేక్ టైం. లిసన్ అండ్ థింక్. ఓకే, సో హియర్ చాలా ఈజీగా ఒక ఫార్ములా తీసుకొచ్చేసాం. చూడండి, ఇక్కడ చాలా ఈజీగా ఒక ఫార్ములా తీసుకొచ్చాం. Very easy method, we came to a destination that we derived a formula from this. Okay, so here one small note. Force is a vector physical quantity and electric field intensity is also a vector physical quantity. It means that electric field strength or electric field intensity will have a magnitude and direction, and force also will have a magnitude and direction, where Q is a scalar which has only magnitude but not a direction. Only magnitude but not a direction. Okay, all children, you do one thing. Draw the arrow marks for this and this. Okay, so while drawing this arrow marks, please remember my words. Okay, dots are there. Okay, thank you.